Hello, Matthews. Gatos here. Welcome to 6.4 word problems. Before I get into the word problems, let's review solving equations. So again, because this is a review question, I do recommend you pause the video, try the solution, come back, see how you did. So in this question here, what I want to do is factor my denominators so that I can find my lowest common multiple and also my non-permissible values. So first thing I notice is I have a difference of squares. So z minus 2, z plus 2. Here I have a GCF of 6. And here z minus 2, I can't do anything with that. So let's talk lowest common multiple. I'm going to need one of each factor. So I need a z plus 2. I need a z minus 2. I need a 6. Let's throw that up front. A z plus 2, which I have, and a z minus 2, which I have. So that would be my lowest common multiple. Let's now talk about the restrictions. We have two factors, so double trouble. Notice that I don't necessarily need the 6 with the z plus 2 because my first step would be to divide both sides by 6, getting rid of it anyway. So here, opposite of a plus 2 is a minus 2, and opposite of a minus 2 is a plus 2. So my restrictions are that z cannot be plus or minus 2. So because this is an equation, I am going to multiply each term by the lowest common multiple, and I'm doing it to every term on both sides to make it fair. So again, I know it's a bit of a pain to write it all out, but if you do, I feel you're less likely to make a mistake. So let's go ahead and cancel. So multiplying and dividing are inverse operations. So I just look for all the pairs that I can cancel. Oops, that one's not correct. It's this one. And then z minus 2, z minus 2. So on the left-hand side, I have 6 multiplied by 2 plus z minus 2 times 10. Let's just use the distributive property here. Equals 2 on the other side, 6 times z plus 2. So that's 6z plus 12. Notice I have no fractions left. So that means I'm on the right track. So it appears that I have a nice linear equation. Let's group our like terms here. 12 take away 20 is 8. And with a linear equation, I want variable on one side, number on the other. So let's get rid of our 6z by subtracting it. 10z take away 6z is 4z. Then I'll get rid of my 8 by adding it to both sides. And then I have 4z, that looks like 42. It's a 4z equals 20. Divide both sides by 4, and I get that z equals 5. So the first place that I check it is against my non-permissible values. 5 is not one of the restrictions, so it looks like I'm good there. Second place that I check it is in my graphing calculator. So I'm going to go back to my original equation, left side in y1, right side in y2, and I'm going to start my table. Table start is second window. I started at my solution, which is 5, and I look at my table and I see y1 equals y2, so I know I did that correctly. So in this video, we're going to talk about solving word problems. Let's review the steps. First thing I want you to do is define all your variables and then state your equation. You're going to state your non-permissible values. Now those are the restrictions of the original equation plus the implied restrictions. Because these are word problems, we might have implied restrictions. For example, time can't be negative. You can't sell half a movie ticket, for example. So you're going to go ahead and then solve the equation and check for any extraneous roots that don't match the restrictions or the implied restrictions. Check your answer in the original equation and against your restrictions, and answer with a sentence with units. If we start with words, we end with words. So those are all the steps that we're going to be following. Let's try this example. So Amber drove 404 kilometers from Edmonton to Banff in the same amount of time it took Mateo to drive 364 kilometers from Edmonton to Jasper. So sounds like Amber has a little bit of a lead foot. She's speeding if she drove at the same time for a longer distance. And in fact, she drove 10 kilometers an hour faster than Mateo. What was Mateo's speed? So in these tables here for distance, speed, time, I have a little tip for you that I want you to follow. The problem with these tables is that sometimes we try to put too much information into the table. So my tip for you is to fill, calculate. Here's what I mean by that. Fill in the distance, fill in the speed, calculate the time using this formula. Time equals distance divided by speed. So let's go back and decide what my variable is. Oftentimes the question that you're asked is the variable. So see how it says, what was Mateo's speed? I'm going to make that my variable, because Amber is compared to Mateo's speed. Amber drove 10 kilometers faster, 10 kilometers an hour faster than however fast Mateo drove. Now Amber's distance was 404, Mateo's distance 364. So I have done fill, and now I'm going to do calculate. So I know that time is the ratio of distance over speed. Distance over speed. Now I have to try and come up with an equation. Well, for the time, if you read the question again, there's information about the time to come up with the equation. And here it is right here. The same amount of time. So Amber's time is the same as Mateo's time. And that's the equation that we're going to solve. So over here is my equation. Let's first come up with the lowest common multiple, and then we'll talk about restrictions. So the lowest common multiple between x plus 10 and x, I need one of each factor. So I need an x plus 10, and I also need an x. Let's now talk about the non-permissible values. So looking at my restrictions in the denominator, I have those, but I also, because this is a word problem, have other restrictions. So this is a triple threat. We have 2 restrictions for the equation and 1 implied restriction. So my restrictions for the equation, x plus 10 can't be 0, so the opposite of plus 10 is minus 10, and a monomial of 0. Now let's talk about the implied restrictions. What does x represent? We chose it to represent Mateo's speed. You can't have negative speed. So the speed has to be greater than or equal to 0. So we want to try and find a way, if possible, to combine all these restrictions together. So first of all, it can't equal 0, so I know it's greater than 0. And it can't be negative 10. Well, that's taken into account with the implied restriction. So here's my restriction that covers everything. It shows that speed can't be negative. It shows the denominator can't be negative 10 or 0. Now we're ready to solve. So to solve this, I'm going to get rid of my fractions by multiplying every term on both sides of the equation by the lowest common multiple. So to do that, I multiply by x plus 10 and divide by x plus 10. I multiply by x and I divide by x. Let's see what we're left with. 404 times x equals, let's apply the distributive property, 364x plus 3,640. Okay, I have a nice linear equation. So to solve my linear equation, I want variable on one side, number on the other. So I will subtract 364x from both sides. And then we have 404x, take away 364x, that's 40x, equals to 3,640. And then I will divide both sides by 40. And I get that x is equal to 91. So I'm going to state my solution with units and a sentence once I know it's actually the solution. So first thing I do is I check it's greater than 0, looks potentially good. Then I go into my table, left side of the original equation in y1, right side in y2, start your table at 91, and you can see those two values are equal. So then I'll end my sentence, or my question, with a sentence. Mateo traveled 91 kilometers per hour. And then we're done. Let's try another one. So in this one here, it's also a distance, speed, time question. So again, remember, we are going to fill, calculate. Fill, calculate. Let's read the question. So a boat which moves at 36 miles per hour in still water travels 28 miles downstream in the same amount of time that it takes to travel 20 miles upstream. Find the speed of the current. So notice it said the boat moving in still water. Well, that would be pretty much impossible to be in completely still water. There's always some sort of a current. So the method that I'm going to use for this question with a boat with current would be the same idea that I would use for a plane with headwind and tailwind. So let's look down here at the tip that I have for you guys. Okay. So looking at my tip here, we're going to talk about upstream versus downstream. So you can see in my little illustration there, the direction the boat is going compared to the stream. So see how the stream is going to the right? If the boat is going to the right, it's going downstream. They're going in the same direction. Now, if that happens, the boat goes faster. You're going to take the boat speed plus the current speed. So going downstream, I'm going to take the boat speed plus the current speed. Going upstream, so you can see here the stream is going to the right, upstream is going to the left. The stream is going in the direction of left. So the boat and the current are in opposite direction. So you're kind of fighting against that current. So you're going to go slower. So the boat speed will be subtracted by the current. Okay, so downstream, I'm being pushed, I go faster, that's why I add. Upstream, I'm being pushed back, that's why I subtract, and I'm going slower. So let's go up here and see, what are we trying to solve for? We're trying to solve for the speed of the current, so that's C. The boat speed is 36, so my speed is 36 minus C, 36 plus C. So I have done my fill and my fill. Now I do my calculate. Time is distance divided by speed. Distance divided by speed. My equation is going to be related to time. So you can see I've already underlined it. It's the same amount of time. So the time upstream will equal to the time downstream. And that makes sense because the distance downstream is longer because I'm going faster. So let's go ahead and solve that. First of all, we'll state our lowest common multiple. So lowest common multiple, I will need one of each factor. Let's talk restrictions. I have two restrictions for the equation, but this is a word problem, so this is a triple threat because I have my implied restrictions. So since C is the current, it has to be greater than 0. You can't have a negative current. Let's look at the restrictions for the equation. 36 minus C can't be 0, so C can't equal 36. 36 plus C can't equal 0, so it also can't be negative 36. So let's try and combine these together. It has to be greater than 0, which covers the negative, but it can't equal 36. So my restriction is going to be C greater than 0, but not equal to 36. Okay, now I'm ready to solve. So I'm going to multiply each term, both sides of the equation, by the lowest common multiple and look for things to cancel. So multiplying by 36 minus 6 and dividing are inverse operations. They undo each other. Multiplying and dividing, those are inverse operations and they undo each other. So now we're just going to apply the distributive property. So over here, I'm going to distribute 20 inside the brackets. So I'll do 20 times 36 and 20 times C equals to, on the other side, apply the distributive property. So I have 28 times 36, 1008, subtract 28 times C. So I have a linear equation. I want to get variable on one side, number on the other. So I will add 28C to both sides. And I will subtract 720 from both sides, so I get the number on the other side. So that's 288. So now all I have to do is divide both sides by 48. And C equals 6. So let's check that on the calculator to see if I did that correctly. So on the calculator, you can see I have left side in Y1, right side in Y2. I start my table, second window at 6, and I do in fact have a match. So let's end with a sentence. So I can say the current is traveling 6 miles per hour. And then we're done. Okay, let's look at another one here. So this is a job share question, and those aspiring lawyers out there, they have questions like this on the LSAT all the time. So this would be a good question to pay attention to for my future lawyers. So this is called a job share question because you're usually given the time it takes one person to do their job, the time it takes another person to do their job, and then you find out how much time together. Or you're given the time together, and one of their times you find the other time. So a couple variations on this question, but the method that I use works for either variation. So Barb can clean the kitchen in 3 hours. Giorgio takes 5 hours to clean the same kitchen. How long would it take Barb and Giorgio to clean the kitchen if they clean together? So let's fill in the table. This is different than distance, speed, time. I'm filling in everything. So Barb takes 3 hours, Giorgio takes 5 hours. We don't know how long they both take. That's my variable. So what I'm going to do is I look at their total time, and it's different, like 3 hours, 5 hours, X hours, they're all different. Let's take it down to a unit rate. So a unit rate, I hope you remember from junior high, is the time it takes to do a job, or how much you do in 1 hour. Unit meaning 1. So in 1 hour, Barb cleans a third of the kitchen. In 1 hour, Giorgio cleans 1/5 of the kitchen. And together they both clean 1x. I don't know what x is, but 1x of the kitchen. Now what we're going to do is build it up to the total. So they're both working together, and we want the total job. So see here how this is 1 over x. I am going to multiply by the total because I want my last number in the table to equal 1. So I'm going to multiply by x. Okay, multiply by x because I want this to equal 1 because I'm looking at, this is the total job. So this is 100% of the job. So let's look at Barb's contribution. So x times 1 over 3 is x over 3. So however long it takes, Barb contributes a third of those hours. However long it takes, Giorgio contributes 1/5 of that time. So my equation is going to be x over 3 plus x over 5 equals 1. So this number will always be 1 because that is 100% of the job, all of the job. So let's look at how do we solve this and what are my restrictions and lowest common multiple. So here the lowest common multiple between 3 and 5 is 15. So I'm going to be multiplying every piece of that equation by 15. Now let's talk about the restrictions. Because I'm dividing by a number, there are no restrictions for the equation, but for the question there are restrictions. Only one, and that's an implied restriction. Now if x is the amount of time it takes them to both clean, first of all we know time can't be negative, so it has to be greater than or equal to 0. But let's think a little bit carefully. If Barb was cleaning the kitchen in 3 hours and Giorgio was cleaning it in 5 hours, if they work together, they're for sure getting it done in less than 3 hours because Barb by herself could do it in 3 hours. So I know it's greater than 0, but it's actually also less than 3. So I know that my final answer will be greater than 0, but less than 3. So it's going to be in between 0 and 3 hours. So let's multiply everything by 15 to get rid of my fractions. So here I have 15 divided by 3 is 5. 15 divided by 5 is 3. And now I have no more fractions. So I have 5x plus 3x equals to 15. So this is 8x equals 15. Then I'll divide both sides by 8. And I get that x is equal to 15 over 8. So if you and I were in conversation and you said, you know, hey, it's going to take Barb and Giorgio 15 out of 8 hours to clean the kitchen together, I don't think you would say it that way. You would actually tell me in a decimal. So it's going to take 1.875 hours, so less than 2, which meets my restriction. So it looks like I'm on the right track, but to know for sure, I go into my table. So left side of the original equation in y1, right side in y2. I start my table at 1.875, and I see that I do have a match, so I know I did that correctly. So when it comes to equations and in life, let's face it, if you're not part of the solution, you're part of the problem. I want you guys to go ahead and do practice questions 2 to 8, detailed solutions on D2L, and then you can move on to your homework questions. So I hope this video helped, and I look forward to seeing you for the next one.